What is a WebSocket and why do we need it? WebSocket protocol. WebSocket protocol is low overhead binary protocol. Since we are in New York, we work in with systems that are pretty heavy loaded and require fast demand and low overhead, right? Wall Street and so on. So HTTP may not cut it over there. So we want to embed WebSocket protocol into our Angular apps, right? So where exactly you may need to have WebSockets? On this slide, I show you a bunch of apps which can benefit from it. Live trading, any auction, any sports event, sports notification, medical equipment, chats, multiplayer games, and real-time updates and social stream, and so on. Lots of application for using WebSockets. What's wrong with HTTP? HTTP is a half duplex. What is half duplex? It means we have one connection, and I can either send a request over there, and then when the response comes back, it'll reuse my connection to tell me something back. So it's like a narrow bridge. You know, like you have a river, you have cars that can go either that way or this way. Also, huge overhead, huge. You want to send 3 bytes, and it'll attach 300 bytes of HTTP headers. Response come back with another 300, 400, 500 bytes with HTTP headers. So it's not useful in a situation like high-level, high-speed trading or something like this. WebSockets, on the other hand, it's a full duplex. It means we have one connection, and these cars can travel back and forth at the same time. No overhead, literally, 2 bytes. You want to say 3 bytes, the whole package, the whole frame will be 5 bytes. That's it. So really, really fast. And how we can work with WebSockets. By the way, it's supported by all browsers, all servers, regardless of what platform you use. This is an example of a plain JavaScript client that uses WebSocket object. This red arrow is pointing you at the creating an instance of the WebSocket with a certain URL. Once again, WebSocket is a browser object. You don't need to install anything. Take a look. I'm not using HTTP over here as a in the URL. I use WS. You can use WS for WebSockets or WSS for secure WebSockets. So I'm saying that apparently there is somewhere a server running on a port 8085 which supports WebSocket protocol. WebSocket protocol is event-based. You specify your callback. What do I need to do if connection happens? What do I do if a message comes in? If an error comes in, if a socket is closed. So pretty simple. WS on message, if the message comes in, I want to execute this function. In this case, I am finding the element on the UI, and I assign some data that I received from the socket on the UI. On error, I do another processing. Down at the bottom, I give you file names. If you decide to try all these examples, they're pretty much all in the book in chapter 13, and GitHub has a repository. So when at the last slide, I show you the URL of the GitHub, so you can get all these examples and run them and try them at home if you want. So let's talk about the server. In this example, I'm using Node.js. You can use Java, you can use C#, .NET, whatever. So in this case, I'm using a Node.js server. What do? I start 2 servers on this slide. By the way, this is the whole code of the program that starts 2 servers. One HTTP server that, in this case, I am starting it on the port 8000. And 2, I'm starting the WS, WebSocket server. I added a little package called WS to Node.js, downloaded from NPM, and you get the support of WebSockets. By the way, when you start a server right, in Node.js, you can execute a callback that will do something on the server startup. In this case, I want to print the local host and the port, or the port in this case. Who knows what are these curly braces around the port? What does he mean? Anyone? Who wants socks? What, Shannon? No socks today for you. Who else? What is that? No. What's that? Guys, do you know JavaScript? Anyone? What? Excellent. You got socks. This is called destructuring. I will not be running around, so please come over if you need it. So it's called destructuring. ECMAScript 6. How come you don't read it? We already have ECMAScript 8. What is destructuring? Destructuring is ripping apart an object. You have an object that has 20 properties. You just need 1 or 2 or 3. Curly braces on the left-hand side of the equal sign means destructuring, extracting just the properties that you need. I just need port. Apparently, this function address will return me more than just port, an object with many properties, right? All right. Now, what happens is if you are connecting using HTTP first time, and then from within your program, you issue another call, like create WebSockets, WS, and domain, host, and port, your browser makes a request to the server. Do you support WebSockets? I want to use different language. WebSockets is a different language, right? So, and if the server says, yes, I can speak this language, then what happens is protocol upgrade. Take a look at that code, 101, that green dot, see that? So the protocol was upgraded, and from now on, the conversation goes over the socket. No HTTP anymore. So this 101 means a successful upgrade. And a little demo. How can you push data to this JavaScript client? You know what? I'll skip this demo because we lost some time. This demo basically is the same code that you saw on these 2 slides. I'll start with Angular demos. So how do you use WebSockets in Angular? 2 ways. The first case is very simple. There is an object WebSocket in the browser, right? Create a wrapper, like an Angular service in there. And whenever the socket pushes you some data, create an observable that will relay the data forward, that will push the data further down, and subscribe to it. That's one way. And I'll show you an example of the code, how you can wrap up a WebSocket object inside a service. Case number 2, you can use RxJS. RxJS comes with a pretty robust implementation called WebSocketSubject. It is already there. You can just use it. It's a wrapper around the WebSocket object. So you can use it, and this is what I'll show you as well. So how do you wrap a WebSocket object in a service? First of all, let's take a look at this little diagram. Imagine that you have a server on the left, somewhere on the left, which supports sockets, and you have an Angular client. Inside the Angular client, you create a service that wraps the socket object. Socket object connects to the server socket, and they start talking to each other. Then you inject an observable service into your component, and component receives messages. The component subscribes to messages, and shows them on the UI, for example, or does something else with them. And now let's take a look at this code, how to wrap up a WebSocket in an Angular service. So what do you see? I have a class, WebSocket service. I declare a variable for WebSockets. And by the way, WebSocket has different states. And if the state is equal to 1, then they call it the ready state. I declare this variable 1 and it's initialized with 1. If the ready state is 1, it means the socket is open. You can send the data back and forth. In this service, I created 2 methods. They are in bold. Create observable socket and send message. Create observable socket, I pass a URL string where I want to connect to, and it's supposed to give me back an observable. So what do? I create an instance of WebSocket inside this function. It's a standard JavaScript. In any browser, you can do this. And then I say, return an observable. What do you need to give to this observable? What observable needs? What object observable needs? An observer, right. And how about subscriber? What's the difference between subscribers and observers? Observer is receiving part, that's right, and subscriber is the receiving part as well. So what is the difference? All right, let me give you an example. Imagine, what is RxJS about? You're pushing data, right? You have a data producer, then you have an observable. Observable pushes the data to whom? Take a look. Let me give you an example that I use in my trainings. Say you have a printing machine that prints magazines. A mailman is an observable. A mailman carries the magazine. Imagine that this is a women's magazine, right? Now, let's take a look on the other end, on the receiving part. Imagine Brad Pitt and Angelina Jolie. Can you imagine them? You can. So everybody knows that Brad Pitt has enough money to subscribe to magazines, right? Agree? Yes. But he doesn't want to read women's magazines, right? On the other hand, Angelina Jolie has no money to subscribe for magazines, but she knows what to do with them, right? So Angelina Jolie is an observer, an object or a subject or a person who knows what to do with the data. And subscriber is an object or a function that brings together observable and observer. That's the difference, right? So observer just handling the data. Subscriber brings them together, that's it. So this function will return an observable, right? And we assume, so whoever, we assume that whoever will subscribe will give me an observer. Okay, let me try again. I'll ask you a question. What is this observer? Who's going to give me this observer object? Where I'm getting it from? Now, when you will invoke subscribe, you will pass an object, which is an observer. So I assume that somebody will subscribe to me, I, meaning observable, and they will give me an observer. And I'm saying whenever the WS on message, whenever the message comes through the WebSocket to me, what do? I invoke next. Very clean API, observable observer. I can call next, I can call complete, and I can call error in case of error. I can call it on which type of object, on the observer. That's correct. So we invoke all these. So whatever WebSocket gives me, I invoke on the observer. So the same API. Now, send message, it's all the way around. If the client wants to send a message to the server, give me a message. I'm checking if the state is open. Then I invoke send on the WebSocket, standard API. This is a WebSocket service. Now, how do you use it in the component? In this case, I created already a WebSocket service, right? I inject it into component. And what do I do in there? I invoke this.ws service, create observable socket. I invoke a method in my service that I just showed you, right? Going back. I'm passing a URL, and I'm saying connect to it. So I'm not saying that, sorry. The server knows what to do, right? The server, going back a slide, the server creates a new instance of the socket for this URL. Hopefully everything is fine, but we subscribe to it, so we will know if it's fine or if it's not fine. So if it's fine, I invoke this dot message from server equal data. Whatever I received, I assign it to this property, and apparently I show it somewhere on the UI. In case of error, I show the error or complete of the stream. Then, if I want to send a message to the server, I use my service, again, the wrapper around the WebSocket, and I say this web service.send message, and I say hello from client. Then I do close socket. Look at this. I also have ng on destroy. Let me ask you, do I have to write it or not? Yes. Is there any way to rewrite this code so I don't have to write it? Async pipe. If you use async pipe on the UI, you don't have to unsubscribe. You don't. So this code is wrong. I mean, it works, but it's not perfect. So if I will be using async pipe, I don't need ng on destroy. I don't need to implement that on destroy. I don't need to subscribe over here. I just need to invoke the function that return me an observable. That's it. On the UI, I subscribe to that observable. So don't write it like this. Actually, you can write it like this if you need data for any other reason but showing it on the UI. If you need to show it on the UI, don't do this. Use async pipe. All right, so this part is done. Node server, what about the Node server? The server side. This is a server that will be talking to my client, and in this server, what do? I also subscribe to connection message. I am using this package WS, right? That I installed using npm install WS. And I say, I want to create a new server on port 8085. And I'm saying, whenever you're going to get a message of type connection, you're going to get a reference to that remote client, whoever connected to you. So this, I assume that they will give me that object and my variable WebSocket will represent it. So what I'm saying is I want to send you something immediately. By the way, I never mentioned that WebSocket is not a response request protocol, meaning any party can initiate a conversation. And it's super, because if a server knows about price change of the stock, it doesn't have to wait for the user sitting there and clicking, do you have something for me? No. Maybe now? No. Maybe now? How about now? No. It's if the server gets something to the client, boom, it pushes the data. Push versus pull. So whenever we want, we can push. So in this example, as soon as a client connects to me, I'm doing send. The client didn't ask me for anything, right? There's no request. I'm just saying, I want to say hello to you. So this is a data push. Using a RxJS WebSocket subject. So a RxJS subject, it's at the same time, it's an observer and observable. One or more, by the way. So since the subject is an observable, it can what? It can push the data to the observers, right? And since it's an observable, you can subscribe to the data. On the other hand, since subject is an observer, you can invoke next error complete on it. 1 of 3. Down there, you see some code. I created a new subject, and I created one subscriber, another subscriber. Sometime later, I do my subject.next 1, 2, 3. This 1, 2, 3 will go to each and every subscriber, whoever exists now, because the subject maintains the collection of all subscribers, of all observers, sorry. So each of them will get it. So multicasting, broadcasting, you call it whatever you want. Now, our subject has lots of different usages. My favorite one is behavior subject. It's very handy for state management. But in the context of our talk, it's WebSocketSubject. They created this class as a wrapper for WebSockets. It's very logical map between what RxJS can do with its observable and observable. Push the data, subscribe to the data, and what WebSocket does. So they give you an object right away. So what do we need to do? You just need to pass a URL where you want to connect, where is your WebSocket endpoint, and subscribe to it, and that's it. It's done. If you want to send something back to the server, you invoke next. Why? Because it's a subject. The subject is an observer, so you can invoke next on it. The subject is an observable. Because of that, you can subscribe to it. Agree? So you got this nice little subject. Moreover, under the hood, it maintains the collection of subscribers. And if nobody is there, nobody cares to listen, it maintains a buffer. So if the server keeps pushing data, it maintains a buffer under the hood. And when the subscriber comes in, it'll do it. It'll replay it, so to speak. So when a server pushes the data, I will show you a demo of an app that is like a sample demo for the auction, online auction. People can bid on products. And when you bid on product, somebody else may bid on product. And if you decided to watch some product and somebody else overbid you want to get a push, right? You don't want to sit looking at this sunglasses that you want to buy and keep hitting refresh, right? If somebody will place another bit, boom, you get a push over the WebSockets. I'll show you this example in a couple of minutes. And how you can implement service, a service that works with a WebSocket subject. This is example of the code that I will be running now, and of course it's on the GitHub. So what do I do in there? First of all, I need to decide what am I pushing? What kind of objects am I pushing? I define an interface bid message with two properties, product ID and price. Remember, it's an online auction. It has a product and a price. I want to monitor a specific product. So I want to get notification about this product. Question. I decided to define this new type, bid message, as an interface. Could I do it as a class instead of interface in TypeScript? Anyone? Yes? Yes, the answer is correct. But the question number two, what do you think is better? Define the type as an interface or as a class? Why using interface to define a type is better than using a class to define a type? Look at this. JavaScript does not support interfaces, which is great. Why? Because during compiling this TypeScript code, this interface will be gone. It'll evaporate. It will not be placed inside the compiled JavaScript, right? If I would use class over here, it would compile into JavaScript. So if I will have 100 interfaces in my project, imagine how much saving you have in terms of number of bytes in the compiled code. So use interfaces for types. So we have a bid service. In there, I declare a variable of type WebSocketSubject. And I have a getter over there, get WebSocket. So somebody, apparently, I will inject this service into a component, and that component will probably subscribe to me or push some data to me. So what I'm doing, I'm saying getter. In the getter, if somebody wants to do something with this subject, I want to check first, maybe it's already closed, right? Or actually, maybe it doesn't exist, it was never created, or maybe it is closed for some reason. If it is closed, then I recreate it. Otherwise, I return what I have. So in this case, I have price update. What is the type of this price update? Observable, right? And naming convention says you should be adding $sign at the end of the variable name. So I have a getter price update. And I say this.subject.asObservable. We know that the WebSocketSubject is a subject. We know that a subject can have two parts to it, right? Observer and observable. And over here, I'm saying, give it to me as observable, cast it to observable. I just need an observable portion of you. Why do I do this? When I have a subject, if I think that these guys should be only subscribing for data and not pushing anything back, I want to stop them. I want to limit them from this. How? I will give them only an observable portion of the subject, which means they can only subscribe. They cannot invoke next, error, or complete on it. All right, so I get an observable, so anybody can subscribe to it. And I have a function place bid. If somebody will click on the button, I invoke next on the subject, right? Subject is an observer, so I can invoke next. And finally, before I do this little demo, I want to mention a protocol. If you are using any kind of a messaging system, anybody is using messaging system in the room? Yes, 1, 2, 3. 3 people in the room. On the server side, I mean, like ActiveMQ, what do they have? RabbitMQ, something like this. What? Yes, TIPCO RV, right? It used to be called TIPCO, correct. MQ series, I remember, right? Now it's called WebSphere MQ. So if you want to integrate messaging system with the client that uses WebSockets, you need a protocol. Basically, you need to say, I have certain queues in my messaging system, and when the user clicks on the button and invokes the send message on the socket, basically this message should go into a queue, right? And on the other hand, if the server places something on the queue for me, subscriber can extract it from the queue and maybe show it on the UI. So it's a very nice match. And you need a protocol. How do you bring these two together, messaging system and WebSockets? There are different protocols, and one of them that is pretty popular is called STOMP. It's a simple text messaging protocol. I don't remember what these letters means. So what happens is, whoever is responsible for the server, being the Java server or any other server or Node.js, they, let's say they have a messaging server over there on the right side. It has queues, it has topics, it has everything. Now, they need to have a server that supports STOMP. For example, ActiveMQ messaging systems support STOMP without the need to do anything special. But if there is a need, there are adapters, connectors that they can install it. And they can say that this WebSocket, this particular one, when it's going to get a message, it should be going to this particular queue with this name, or for this topic with this name. And the rest is the same. It's pretty much the same. And you can read the docs, and the links are there. So now, finally, I'll run an app. And in this app, 1 second, I will need to click on something on the screen. In this app, actually, there are two apps. One of them is server, and the other one is client. The server app, let me do clear. And what I will do over here, I will run the server. The name of the server is built. It's a Node.js program. The whole support of the auction is there. Basically, I'm starting the Node server, and in particular, I am starting the app, the regular server. And somewhere in there, I'm starting the WebSocket server as well in a different file. I will not be going through the server, but both HTTP server and WebSocket server can share the same port. Moreover, they can use port 80 and port 443 because it's a standard. So your system admins who are responsible for the firewall, they will not complain that you're using something weird and need to open different ports. You don't need to. So anyway, so I will start this server. It's up and running on port 1990. Then I'll go to the project called NG Auction Client, and this is an Angular app. And in this Angular app, I have that service that I just showed you on the slide. This is the guy, the BidService, right? That's the same guy from the slide. And the product detail component is the one that is using the service. So where is my constructor? Right there. See, I'm injecting this BidService into my component, and I will subscribe to it. As a matter of fact, in this app, I go to product detail, and there is a button, place bid. This is how I can send the data, and I can receive the price changes by other bidders. But that page, I will show you, it has also suggested product. What if the user will click on a different product? I'm looking at the product A, and around it, like in Amazon, right? People who buy this also consider buying that. So if I will change the product, it's another observable. So I can have two observables, and I bring them together using combine latest. Product changes is for the case when the user decided to look at different product, and the BidService is the guy from that WebSocket server. So let me run this app, ngserve. Let me run this client app, and I'll go to port 4200, and it'll hit that server, and it'll start the app, and we'll be done for today. So the build is almost ready, done. So I go to localhost 4200, and I have this auction app, right? So this is an auction. You have different categories. You can check the products. You can go to specific product details. See, on the right-hand side, you see product details, but on the left, you see more items to consider. So this is one stream. And if I decide to monitor sunglasses, for example, I can place bid on them if I want. See, this goes over the socket to the server. Now, if I will, let's say, I want to do what? I want to open up another browser as if I'm a different user, right? Let's say I'm a user 2 now. I also open up, I'll hit the same app, the same server. I go, let's say that guy sitting around somewhere else, he wants to place bid on the same sunglasses. So see, I will be clicking on the right, and you will see how the server will be pushing to everybody who decided to monitor. See this? I can click over here, and everybody will get it. So I send a message that I want to place a bid. The server will get it. The server maintains subscriptions of everybody who is interested and broadcasts to everybody who is out there. That's the architecture of this app. This part is HTTP completely. This part is WebSockets. The URL of the server can be injected from the environment file that every Angular app has. All right, so these are the instructions if you want to do it at home, how to start separately server and client. And these are the links if you care, if you want to try them. This is a GitHub repository, in particular, those examples that I showed you today. That's it for today. Thank you very much.